Very good morning, students. Today we continue our Mathematics 1 lecture with the chapter Partial Derivative, and the topic is Directional Derivative, Tangent Plane and Normal Line. Okay, so before going to start the Directional Derivative, I just want to ask you the formula of the gradient. Uh, Anyone? Please raise your hand. I just want to the formula of the gradient. Yes, VP.
Hello.
Yes,
The formula of gradient is grade f is equal to I cap del f
yes.
by del x plus j cap del f by del y plus k cap del f by del z.
Okay, very good. Thank you. So, students, now the definition of the directional derivative, that is the directional derivative of a function f of x, y, z in the direction of vector A is the component of grade f. This is the gradient in the direction of A bar. It means if unit vector A, that is A cap, in the direction of A bar, and the directional derivative of f in the direction of A bar is given by, this is the main formula for you, which will help you in the example for the calculation of the example. See, this is symbol D, A. This is for directional derivative. This is our function. This one is f. Okay. Now, the directional derivative of f, that is gradient of f into unit vector A. Now, what is the unit vector A? Unit vector A means vector A upon modulus mod A bar. Okay. So, this is just for your knowledge. It means any function in the direction of any vector is the component of gradient of f in the direction of that vector. Okay. Uh, See, in exam, no one asks you the definition of the directional derivative. They just ask you the example. Okay. So please keep remember this formula. That is the directional derivative of f is gradient of f dot a cap is equal to gradient of f a bar upon mod a. Okay. So let's start the example. Okay, but before going to start the example, I just want to know, anyone know the dot product of two vector? Suppose I give you one vector, that is I cap plus 2j plus 3k dot I cap minus 2j plus 2k. Okay, so what is the dot product of these two vector? Many students are giving the answer is 3. Yes, because here I cap dot I cap. So multiple of I is 1 into 1. I dot I is 1, and here 1 into 1 is 1, plus 2 into minus 2, that is minus 4, 3 into 2, that is 6, 6 plus 1, that is 7, 7 minus 4 is 3. Very good. Approximate 15 to 17 students have given the answer. Okay, and thank you. You all are right. So, start the example of the directional of derivative, that is find the directional derivative of f is equal to xy square plus yz square at the point 2 minus 1 1 in the direction of the vector, I plus 2j plus 2k. Okay, so this is our question. Now start the solution. Here our given function is f, okay, and as you all know the formula of the directional of derivative, first we want to find the gradient of f, and then we have to multiply dot product with a cap, right? So now the formula of the gradient of f, that is I cap del f by del x, j cap del f by del y, k cap del f by del z. Okay, so the derivative of f with respect to x, that is here derivative of x with respect to x is 1 and y square is multiple, so y square keep it same, and in the second term there is no x, so the derivative of second term is 0 plus j. Similarly, the derivative of f with respect to y, here we are doing the partial derivative. So the derivative of first term is 2xy, and the derivative of second term with respect to y, that is z square plus k. Now the derivative of f with respect to z, there is no z in the first term, so this is constant, so the derivative of first term is 0, and the derivative of second term is 2yz. Uh, Mahir, there is sign mistake. Your answer is, final answer is right, but there is little mistake. Check your sign. Okay. So, okay. Now we are want to find the directional derivative at this point. Okay. So we are first find the gradient at this point, that is gradient of f at 2 minus 1 1. So here we substitute uh, 2 in the place of x, minus 1 in the place of y, and 1 in the place of z, right? So if I substitute minus 1 here, that is minus 1 square. Here in the place of x, I am substituting 2. Here is minus 1, z is 1, okay, 1 square, and k, 2 in the place of y, I am substituting minus 1, and in the place of z, 1. So after simplification, minus 1 square is 1. So this is just I cap. Here, minus 4 plus 1, that is minus 3, right? So here is, this term is minus. Okay. So minus 3j, and last one is minus 2k. So students, we have find the directional derivative at the point 2 minus 1 and we have find the gradient at the point 2 minus 1 and 1, right? Now we want to find the directional derivative in the direction of, in the direction of which vector? In the direction of I plus 2j plus 2k, right? So the formula of the directional derivative, that is TAF is equal to gradient of f into a bar upon modulus of a. Now the gradient of f is I minus 3j minus 2k, right? So this is I minus 3j minus 2k. dot a bar is what? A bar is our given direction, and our given direction is this, I plus 2j plus 2k. So this is I plus 2j plus 2k. Now, in denominator, we want to find the modulus. Okay, so modulus of A is square root of multiple of I square. Multiple of I is 1. So 1 square plus multiple of j square, that is 2 square, and multiple of k, that is again 2 square, right? Now, for the simplification, we first find the dot product of these two vector. So here I cap dot I cap, that is 1, right? J cap j dot j, that is again 1, so minus 3 into 2, so minus 6, and then minus 4. And in the denominator, we have 1 plus 4, right? So 1 plus 4 plus 4. In the numerator, minus 6 minus 4 minus 10, so minus 9 upon square root of 9. So minus 9 upon 3. So our final answer is minus 3. Okay, very good. I have I got the answer from 20 students. Minus 3 answer I got from 20 students. Okay, very good. Thank you. So now, if anybody have any doubt in this example, please ask in the chat box. Otherwise, we'll move for the another example. Have you any doubt? Good. Okay. So let's take one more example of the directional derivative. That is, okay, find the directional derivative of f is equal to x square yz plus 4x z square. X square yz plus 4x z square at 1 minus 2 minus 1. 1 minus 2 minus 1 in the direction of 2i minus j minus 2k. Okay, so let's start the solution. First we find the gradient of f, that is I del f by del x, j del f by del y, and k del f by del z, right? So the derivative of f with respect to x is 2xyz plus 4z square. Same, the derivative of f with respect to y, that is x square z, because there is only one first term in there is y, no y in the second term. Okay, so the derivative of f with respect to y, that is x square z plus k, the derivative of f with respect to z for the first term, that is x square y, and for the second term, that is 8xz, right? Now the gradient of f at the point 1 minus 2 minus 1. So if I put here 2, so at the place of x 1, this is minus 2, and this z is minus 1, plus 4, a value of z is minus 1 square, right? Now j, value of x is 1 square, value of z is minus 1, right? And in the k, value of x is again 1, so 1 square, value of y is minus 2, 8. At the place of x 1, and z is minus 1, right? So here I cap minus minus plus, so this is 2 into 2 is 4, right? minus 1 square is again 1. 4 into 1 is 4. So we directly write as 8. Okay. 1 into minus 1, that is minus. So minus j. In the last term, minus 2 minus 8, that is minus 10k. Okay. Yes, 3 to 4 students have given the answer in the chat box about the gradient of f at the point 1 minus 2 and 1. That is yes, good, very good. And okay, so this is the gradient of f at this point. Now for the directional derivative, in the direction of what is our direction vector? That is 2y minus j minus 2k, right? So the formula for the directional derivative, that is DAF, formula for the directional derivative, that is DAF, here gradient of f dot a bar upon mod a. Now the gradient of f is, see, this is 8i minus j minus 10k. So this one is 8i minus j minus 10k, and the directional vector, that is 2i minus j minus 2k. 2i minus j minus 2k, and the modulus of a bar, that is square root of 2 square plus minus 1 square plus minus 2 square. Okay. Now the dot product of these two vectors, that is 8 2s are 60, minus minus plus 1 into 1 is 1, again minus minus plus 10 2s are 20, upon here 4 plus 1 plus 4, that is 9, right? So here 60 plus 1, that is 17. 17 plus 20, that is 37 by 3. Okay. Yes. 37 by 3. Have you any doubt, students? Have you any doubt? Okay. So this is the answer of the given question. Note down one question for homework of the directional derivative. Then after we'll move for the next topic. See, this is for the homework, right? Find the directional derivative of f is equal to, this is f, xy plus yz plus xz at 1 to 0 in the direction of vector I plus 2j plus 2k. Find the directional derivative of f equal to xy plus yz plus xz at the point 1 to 0 in the direction of vector I plus 2j plus 2k. Okay. Okay. So we'll move for the next topic. Okay, we'll move for the next topic, that is tangent plane and normal line. See students, now I'm going to tell you the geometrical knowledge. This is for your extra knowledge. Okay, no one asks you in the exam, but it will be helpful to you in further study. So first start what is tangent plane. So suppose if we have a plane xyz, right? Then in this plane, suppose we have a 2 point. One is P and other is Q. If we draw a one curve that joining these 2 points P and Q, and this is one chord that is joining P and Q. See, listen carefully. If Q tends to P, if Q tends to P, means if Q is going to near to P, tends to P means if Q is going to near to P, at that time, this curve, okay, this curve tends to this line, agree? Again I repeat, if Q tends to P, then this curve tends to line, right? So at that time when this curve and this line are approximate similar or approximate equal, that line is known as tangent line. Okay, that line is known as tangent line. Now we have so many curves which are joining these 2 points. We may draw like this one, right? Like this one, right? We have so many curves. So it means we have so many tangent lines also. So if we get any plane which pass through this tangent line, that plane is known as tangent plane. Okay, that plane is known as tangent plane. And a line which is perpendicular to this tangent plane, a line that is perpendicular to tangent plane is known as normal line. A line which is perpendicular to tangent plane is known as normal line. Okay, this is the this is for your knowledge. Now we start the formula of the tangent plane. Okay, so the equation of the tangent plane at P x0 y0 z0 to the surface f of x, y, z equal to 0 is, see now this is the main formula, x minus x0 into f of x, x0, y0, z0 plus y minus y0 into f of y, x0, y0, z0. Note down the formula. It will help you in the exam. And this is the most IMP topic for the exam. One question definitely will come in the exam for internal and GTU also from this topic. Definitely 100%. F of z, x0, y0, z0. Okay, see, this is the formula for the tangent plane, that is x minus x0. F of x, x0, x0, comma, y0, comma, z0 plus y minus y0. F of y, x0, y0, z0 plus z minus z0. F of z, x0, y0, z0. Okay, so this is the formula for the tangent plane. Now, the equation of the normal line equation of the normal line to the surface at the point P x0, y0, z0 are x minus x0 upon f of x, x0, y0, z0 equal to, see, this is equal to, right, y minus y0, f of y, x0, y0, z0 equal to z minus z0 upon f of z, x0, y0, z0. Okay, so these two equations are most IMP for you. I hope you have noted down the equations. So let's start the example. Our first question is, find the equation of the tangent line, tangent plane and normal line to the surface x, y, z equal to 6 at 1, 2, 3. At the point 1, 2, 3. Ma'am, please re-show the equation. Okay, Neil. See, this is the equation. See, this is the equation of the tangent plane and the other one is for the normal line. Okay, Neil? Now got it? Okay. So this is the question, right? For now we want to find the equation of the tangent plane and normal line, right? So this is our given function. So let's start the solution. Here f of x, y, z, our given function is what? That is x, y, z. I put this 6 in the left hand side, so that is minus 6. So our given function f of x, y, z equal to 0. So it means here f of x, y, z minus 6 equal to 0. This is our given function. First, we are going to find the partial derivative of this f with respect to x. So I am going to find f of x, x, y, z. Students, the meaning of this, the derivative of f with respect to x. So the derivative of f with respect to x is what here? That is yz, right? Similarly, the derivative of f with respect to y. Okay, so if I am doing the derivative of f with respect to y of this function, that is xz. Here 6 is constant, so derivative of x, 6 with respect to x is 0 and the derivative of 6 with respect to y also 0. And similarly for the z, the derivative of f with respect to z is xy. Okay, now, see carefully and listen carefully. Now, the f of x, the derivative of this x at the point 1, 2, 3, the derivative of f with respect to x at the point. So, here I am going to put 1 in the place of x, 2 in the place of y and 3 in the place of z. So, here yz, so I am putting here 2 into 3, that is 6. Now, f of y, 1, 2, 3. The value of x is 1, right? Value of z is 3. So 1 into 3 is 3. And similarly, f of z, that is 1, 2, 3. So the in the place of x, I am putting here 1 and y is 2. So here 2, right? Now, as per the formula of the tangent plane, the equation of the tangent plane is what? That is x minus x0 into f of x0, y0, z0, right? Plus y minus y0, f of y, x0, y0, z0 plus z minus z0 f of z x0, y0, z0. But we want to find the equation of the tangent plane at the point, at which point? At the point 1, 2, 3. It means our points x0 is 1, y0 is 2 and z0 is 3. So now I am substituting the value, that is x minus, at the point of x0 I am putting here 1, and the value of f of x at the point x0, y0, z0 is what? 6, then 3 and then 2. So here this one is 6 plus y, value of y0 is 2, see this is 2, and f of y is 2, see sorry, f of y is 3, so this one is 3, right? Plus z minus z0 is 3 and this f of z is 2. Okay, see this f of z is 2. So after simplification I have 6x minus 6, 3y minus 6, 2z minus 6 equal to 0. It means 6x, see I am putting 6x, this 3y plus 2z, right? Now this minus 6 minus 6 minus 6, that is minus 18, and I am putting this minus 18 on the right hand side. So this is my answer for the equation of the tangent plane at the point 1, 2, 3 for the given function, right? Now the set of equation of normal line is, that is, as you all know, x minus x0 upon f of x, x0, y0, z0. Here y minus y0 upon f of y, x0, y0, z0, and z minus z0 f of z, x0, y0, z0. And our point is 1, 2, 3, that is x minus 1. The value of f of x at the point x0, y0, z0 is 6. This is y minus 2. This value is 3. Z minus 3. And the value of f of z is 2. Okay. So this is the answer of the normal line at the given point 1, 2, 3 for the given functions. So any doubts, students? Very good. 6 to 7 students have given the answer of the equation normal line and normal line and tangent plane before me. Very good. So have you any doubt? Have you any doubt, students? Okay, no doubt. So we'll move for one more example. Good. So see, students, I know this is easy, but it is still most IMP. Okay, so do the practice. Okay, so let's start one more example, that is find the equation of the tangent plane and normal line at the point -2, 1, -3 to the ellipsoid x square by 4 plus y square plus z square by 9 is equal to 3. Okay, so it means this is our given function and this one is our point, where at point we want to find the equation of the tangent plane and normal line, right? So let's start the solution. Here our given function f of x y z is equal to x square by 4 plus y square plus z square by 9. I keep these three left hand side, right? Now the f of x at the point this x0 y0 z0, that is here. What is the value of here? The given, this is x, y and z. Okay, so what is the derivative of f with respect to x? That is 2x by 4 x by 2, right? f of y is what? That is 2y. And f of z is 2z by 9. f of z is 2z by 9. Yes. Now the value of derivative of x at the point x0 y0 z0, and what is our x0 y0 z0? You can put here x0 y0 z0, or also you can put -2 1 -3, both are same. If you wish here to put x0 y0 z0, that is also okay, right? Now I'm going to put the value of x at the place of x, -2 at the place of x, that is -2 upon 2, right? So -1. Now f of y -2 1 -3. So here 2 into value of y is 1, so that is 2. And f of z -2 1 -3, right? So 2 value of z is -3 upon 9. So my answer is -2 by 3. Now you have to find the equation of the tangent plane and normal line. Okay, you have to prove by yourself. I am just giving you the final answer, but you have to try by yourself. Okay, I am giving you the final answer of the tangent plane. The equation of tangent plane would be 3x minus 6y plus 2z is equal to minus 18. And the equation of normal line, it would be x plus 2 upon minus 1, y minus 1 upon 2, and z plus 3 upon minus 2 by 3. Okay. Students, these are the answers. You have to try by yourself. If you have any query, you can contact me. You can ask me in the next lecture, right? So if you have any doubt for today's lecture, you can ask me in the chat box. Can you see? Okay, Dhruv, you got the answer. Very good. Srishti, can you please show the previous slide? Yes. Yes, Srishti. This one? These slides you want to show, Srishti? Okay.